Window. All right, so.
Updated ones.
Yeah.
Correct.
Yeah, but it's,
It was PDF.
yeah, that's close enough. You can see all the content on it.
PDF.
Yeah.
There's no way I can test it.
Yeah.
So, can we?
Yes, let's boot it up.
Good afternoon. Oh, it works.
Yes.
This is Pass-Aware Networking Proposed Research Group. Please check that you're in the right room. There is a captive portal next door. I almost ended up there. But this is much bigger and nicer room. So, before we start, thanks for Chris who volunteered to be a minutes taker, but we still need a JavaScript. Come on, someone, please.
Aaron.
Thank you. Round of applause.
Try to do that more grudgingly next time. It's like, thanks, Aaron.
So, not well, I think. Yeah, which does not fit very well on the screen. It's updated version. I actually do not know what's the difference, but anyway. Yeah, please read it or check it on the IETF website. We have an agenda. Yeah, it's actually up-to-date agenda. Great. Quite busy agenda, actually. And we have 2 documents on which we'll be discussing today. It's kind of twice more than we had last time. Such a big progress. And okay, so, and now I think we can start with the first presentation. Dan, are you in the room? No. We've lost presenter already. Shall we probably move to another one and then?
We got a couple of minutes.
Okay, we can.
Actually, no, go ahead and call up the satellite guy.
John Border, are you in the room as well? Yes,
Yeah.
please. Oh, cool.
So just come up to the mic and give the real quick version of your hard RSC talk.
Okay. So basically, we're trying to get going discussion on the idea of encrypted protocols like QUIC running over satellite, where you can't do things like PEP anymore to accelerate the things. So you need solutions that can give you the high performance required in a path that has non-trivial latency, like a geosynchronous satellite. We're getting ready to stand up a mailing list to get the discussion going. One of the ideas out there for helping solve this problem is to be aware that it's a satellite path, which is why it's potentially relevant to this group. And so that's why we wanted to bring it up here. And so look for the mailing list.
Actually,
hopefully, if I get on the ball tonight, maybe.
Okay, cool. Could you send that over to our list?
Yes.
Panrg@ietf.org.
Okay.
Cool. Thanks.
So then, okay, are you in the room? Okay, so I think we can just, yeah, let's shuffle. Teresa,
Yeah.
please.
All right. Hello, I'm Teresa from TU Berlin. I'm a PhD student, and
I'll do the next slide.
okay. And so my research is focused on the scenario when we are at an end device and have multiple paths available, for example, over Wi-Fi or over cellular, and usually devices just use Wi-Fi as a default. Thanks. But actually, Wi-Fi is not always the best option. This has already been shown in several studies. So which of the available paths do we actually pick from the end device? If we just use the vanilla BSD socket API, then basically assume we have a bunch of connections that we see here on the left, and then there's the two paths shown on the right at the end device. The socket API cannot distinguish between different kinds of connection. I'm going to come to what exactly that means in a minute. So it does not have additional information on the TCP connections, for example, and then also it has no information about the paths, like about their performance. So usually what happens is it just uses a default path that is based on some system policy, what I mentioned before, just Wi-Fi is used. So socket intents is additional information on the connections. So the application that opens several connections tells us what it wants with the connection, what it knows about it, what it assumes about its own traffic, or what it prefers. This is not quality of service. This is just some hints on what should be optimized for. So let's say, should we optimize for low latency or rather for high bandwidth for the connections? So we have a draft geared towards the TAPS working group, if you're interested in the details. So socket intents can, for example, be the category of traffic. So is this going to be just a query? Is this going to be a byte transfer or a stream? Then there's the size of the content to be received. So think about like an OS update. Is it going to be 100 megabyte that we're downloading? This is information that could be useful for path selection, right? And then also what bitrate is the application planning to send roundabout, which we could know for some video streaming applications, the timeliness or the cost preferences that the application specifies on its connections. It can also specify these properties per message, for example, but I'm going to focus on the connection for simplicity. So now assume there is connection 1, and the application has told us that it's going to be a query and it's only going to be 10 kilobyte. So now the other part that we need is we need some information about the available paths. So in our prototype, we have some property estimates, for example, the median round trip time, the maximum bitrate, or the Wi-Fi utilization. And this is actually the part that I'm going to be focusing on in this talk. So path 1 is LTE. It has a high RTT. It has also a high bandwidth. Path 2 is Wi-Fi. It has a low RTT, but also a low bandwidth. And now our path selection policy in the socket intents prototype can, for example, just be, okay, we're focusing on good performance for the user. And so we want to use the path with the shorter completion time for this query. So our path selection policy has the information available about the paths, and it calculates that over LTE, the query will take about 200 milliseconds. Over Wi-Fi, it will be much shorter. So, well, just use Wi-Fi, right? And then the second connection is going to be a byte transfer, and it's going to be 500 kilobyte. That is expected and specified by the application as a socket intent. And now the path selection policy, if it wants to still prefer the path with the shorter completion time without regarding the cost preferences, so of course it also depends on the system policy and on what the application specifies, but let's assume we still use the same path selection policy, then over LTE, this transfer is going to be completed sooner, so it would use LTE, or maybe if MPTCP is available, it could also combine both paths and just use MPTCP. So our prototype framework is, works the following way. We have an application, it specifies the intents, say for a connection, and then the socket intent library that sits on top of the vanilla socket API, it asks the multi-access manager, which is a standalone application, a daemon that runs and loads the policy as a module. It asks which path should be used for this new connection. And now the multi-access manager makes its decision. It has information available on the paths, and it gets the socket intents from that were originally specified by the application. And now it says, okay, for this particular communication, please use path 1 and use local address A. And now in the socket intents library, we can bind the new connection to address A and then connect. And so now we are using the path that has been specified by the multi-access manager. For details, you can see our draft. So we have multiple drafts, but the draft I link on this slide is the one that actually talks more about the framework and about the implementation. Also, we have code on GitHub. So for Panrg, I wanted to focus on how do we actually gather the information on the path. And so paths in our multi-access manager are represented just as the local prefix that is configured, or it can also be represented as the interface. So we have kind of data structures there, and we gather which prefixes are currently configured on path 1 and path 2. So say we have one IPv6 and one IPv4 prefix on each path. We focus on prefixes because with IPv6 privacy extensions, our actual address might change over time, but then we still have the information for the same prefix available, even if our address changes. And so, yeah, the multi-access manager is a daemon. It runs and it collects information on the current traffic and also keeps some state on the past traffic that it has observed. And so in my earlier example, I simplified it as a path RTT of 100 milliseconds and 10 milliseconds, but actually per prefix, the RTT might be different. And I'm going to go into detail about the RTT on the next slide. So also we can have the bit rate and the utilization and potentially many other properties. So the path bit rate is calculated per interface. And we just read interface counters every 100 milliseconds, or we can also do it more often. And then calculate the current bit rate just using the simple formula shown. So over time, we observe that, so suppose there is a large transfer, we observe some maximum bit rate at some point, and we estimate that this is round about the maximum bit rate that we are currently getting for transfer over this interface. So this assumes that the bottleneck on a path is within the first few hops, because as I said, we assume there are 2 paths available. Of course, after the first few hops, there can be many more paths through the actual internet, but our focus is the access network. And so for each of these paths, we know per interface what we observed roundabout as a bit rate. So this is what we use as an estimate of if this is high bandwidth path, is this a low bandwidth path? And then we keep the state for 5 minutes, but it's also configurable. And then the path RTT is an RTT per prefix. So the Linux kernel keeps a state on the current TCP connections. Every TCP connection has a smoothed RTT. And we query these as RTTs for all connection over a certain prefix, also every n milliseconds. And then we calculate the mean, the median, and also we retain the minimum of the last 5 minutes. So also here we focus basically on the first hop or first few hops, and we expect them to dominate latency, which might not always be true, as we have also seen in some presentation this morning in MapRG. But yeah, so this is our abstraction for paths, and this is the RTT we get. So then also radio properties for Wi-Fi are possible to get on Linux, so we can get the received signal strength and the modulation bit rates, and also for the utilization, there's the QBSS information element in beacon frames and also probe response frames, and we can observe that from our multi-access manager, and then know about what percent of the airtime did the access point observe the medium to be busy. So this is typically either something like around 2% what we observe, or it can be 60, 70% if the medium is really busy where the access point is at. Of course, for other wireless technologies, it would be possible to get statistics, but it's hard, so we currently implement this for Wi-Fi. So currently, we are using our prototype to show that page load time for web browsing can actually be reduced with this approach. So web browsing is basically fetching several objects over several either TCP connections, or it could also, of course, be like quick streams. And it's a series of objects that we download. And through a hack, we know the file size of the objects, and then we schedule the objects on the different interfaces. So what I showed earlier, the large objects go over one path, the smaller objects go over a different path, and then we ask, can we actually find a good link selection or path selection policy in this case that helps us reduce page load time. And then also we are looking for more path selection properties, policies, I meant. So there's one policy that I showed which optimizes for page load time or for object load time is one example, but then there can also be policies that optimize for cost or maybe for energy consumption and so on. And then also we want to find out more about the path. So the variation of the SRTTs can be interesting over time, but also within the SRTTs that we get from the kernel, because say if there's 10 TCP connections on the same prefix, then we get 10 SRTTs and we calculate the mean, the median, but we can of course also, or we also do calculate the variance of these 10 TCP connections that exist in parallel. And also we can observe packet loss, and we can also get more information from the network, maybe, perhaps, but this is not, except for QBSS, this is not implemented yet, but we're still exploring ideas. So as a summary, socket intents is application provided hints on a connection or on a message. And so in our prototype, we know what to optimize for. And then the path properties are gathered locally just on the end device. So right now, the only signaling that is going on is that we get QBSS frames and we observe their QBSS medium utilization and also the median SRTT maximum bit rate. And then we do path selection within our multi-access manager within the policy. And as I said, if you're interested in the details, you can look at our draft or our code. And now I'm looking forward to questions or comments.
Richard Young from Yale. So I think API is pretty cool, but two questions. Number one is, how much granularity you really want to handle? For example, one pass would allow port 80, for example, HTTP, and second pass wouldn't allow it. Would that be considered as an issue, or you don't care about this?
One path allows what exactly?
For example, oftentimes, suppose you deploy SDN, software-defined networking, and on one path you would allow port 80, second path you wouldn't allow port 80, for example. And essentially that's a policy issue that's inside networking information. And you plan to collect those information eventually in your implementation? Or maybe that's really probably you should be designing part of your API?
Yeah, we don't do this yet, but there's a lot of room for like collecting more information on the path, such as which protocols are supported, for example, would be also a really interesting question, right? So are there any middle boxes on the one path or on the other path? And is there anything blocked? And so, but for protocol selection, we are limited by the socket API.
Right. Basically, for example, all this eventually can become very complex. Okay. And the second question will be following. I think API is probably fine, and mostly questions about your intention to handle the path property collection. For example, the available bandwidth, essentially to compute the finishing time, can depend on the dynamics. And for example, depends on the TCP and TCP Reno, TCP Vegas. They have all essentially utility functions, and the bandwidth sharing depends very complex on the bandwidth sharing. Essentially, need to solve the global optimization problem. And do you think that will eventually be in scope, or essential assumption would be okay? And your number one is you probably can approximate using, for example, loss rates. If your flow is small enough, you will not move the market. You probably can approximate by estimating some kind of loss rate. Otherwise, you probably handle some kind of dynamics. Estimate, okay, what if I start with a very large flow and the overall bandwidth allocation of the whole network will be changed, and how do we handle that? Is that really in scope, or that will be considered as total out of scope?
Could you repeat the question a little bit more slowly, please?
Okay, sure. Let me slow down. Okay. So the second question is, oftentimes there's a lot of dynamics.
Yeah.
When you start a flow, and actually the eventual bandwidth you will get depends on your start of flow or not.
Does the bandwidth depend
Right.
on the?
For example, suppose there's 2 bottlenecks or 3 bottlenecks.
Yeah.
And they all kind of very finely TCP cross paths. And the bandwidth is essentially allocated. You could compute using essentially Frank Kelly's equation, utility function framework. Okay, let me take it offline.
Lee Howard, thank you. This is really interesting, good work. Question. So I loved when you were showing the round trip times based on prefix. And of course, I always love seeing examples in IPv6 as well as IPv4, because of course they're different prefixes, and we know there are different latencies on those paths. How does this interact with happy eyeballs?
Well, it would be really cool to use happy eyeballs in our prototype, which we don't use yet. But I think it would be like, right now we just choose one of the prefixes and then we just open our connection.
So you're doing
this is an obvious.
You're doing your own socket
next step.
setup rather than whatever's in the OS. Cool. Good future work.
Thanks.
Hi, Olivier Timons. I have a small question about the measurements you're doing for TCP. So you want something that has low latency, but the thing is, when you measure smooth RTTs, you're measuring up to the TCP endpoint that may be behind proxy. So if well, that's actually an open question for you. That how would you handle it if you wanted an application on top of it that wanted high or a low time to interact, if you want. So bypassing a proxy. So you would, I guess, need to integrate with something else. I don't know.
We could differentiate by endpoint, assuming not all endpoints are behind a proxy.
I don't have an answer for you, but it's something I've observed already that beats me already. So.
Hi, Fabian Schneider, NEC. Quick question. It seems that most of the time the connection initiator would not know the intent that the application has, because it probably is dependent on what the contacted server wants to transmit. It seems like you probably want to explore something in the direction of how to get the intent over from the other side to the connection establishment, or I mean, vice versa.
Yeah, currently we only, like, our prototype is only on one side, on the client side mostly. So the other endpoint does not have to signal us anything. So it depends on the application, and like the application needs to use our API. So
yeah. So I'm just saying, like on a future direction, you probably want to explore some mechanisms how to exchange intent between the 2 endpoints before establishing the connection, or having some other mechanism that leverages multiple options to get data across.
Well, for HTTP, the hack is that we just do a head request of the first, say, 4 kilobytes, and then we get the content length of the entire object, and then we know the object size. So we get the information from the other side.
But then your connection is already established, so you would need to
that's
do
true,
a new one, right?
If the remainder of the object is 1 megabyte, then maybe we want to schedule the remainder over the other path.
Yeah. Okay.
Thanks.
No more questions?
You can also find me offline. I'm here all week.
Thank you. And the next presentation is Daniel. This one.
Sorry for arriving late. I think I needed path awareness to get to the room. So I'm going to present service-aware networking using SR from an operator viewpoint. So there may not be going down to the bits as my previous speaker, but we're going to go see our challenges and where we're thinking about going to using that model for path awareness. So our telco challenges, I'm going to go really fast. The problem statement is what happens and what's the view from our side is, well, you know it, the internet is growing, so it's not big news. Our networks is really static. Some of our network devices in our network still don't support SNMP, so that tells you how much our network is old. We have long migration cycles, so that's a big known fact from every telco. We have hardware becoming obsolete quicker, so there was a big TCAM issue in 2014 that affected a lot of us carriers, and that's the basic approach of, well, the internet is growing. The second thing is our network, we're managing complexity. We added in the past 4 years, at least 3 providers got joined into Bell, so it's getting even bigger as we were. So we're adding different level of networks. We have as a network no end-to-end traffic engineering view. So since we have pockets of networks connecting them together, doesn't mean we have an end-to-end view. And then we don't have any end-to-end OEM for troubleshooting. So that becomes it really becomes an operational challenge and reduce the adds to the complexity of being able to offer services quicker. So our first response was, well, like almost every telco, is let's do network virtualization and transform. So that's an easy way to do, but transform our network to integrate the core with our network, our DCs, to leverage virtualization, include leverage our existing MPLS data plane because we're actually good at MPLS inside Bell. So move towards a vision of pure IPv6 or SRv6 as it progresses, and simplify the control plane, so flatten our network so that we use MPLS everywhere, and a single flat topology so we don't have multiple versions of encapsulation. So for us, the DC looks like a common IP fabric, part of our MPLS network. It's also solved a lot of issues we have integrating services in line from our core network, because since we're in the same forwarding plane, that it reduces some issues. The basic of that transformation, that first phase of transformation, was presented at NPLS World Congress a while ago. The round 2, well, you're an old telco, converting data centers of 70 years old plus into a big new CODC with it's not that easy to do. We're stuck with problems with power cooling. We have the trouble of, if you try to do and transform that into a CO into a DC, all the cost of changing that without necessarily revenue generation is kind of a challenge. Removing old boxes to get enough power, it's still like removing a DMS for us takes about a year. We have 192. So if you think about that, it might take a long time before we're able to convert all of that. Plus virtualizing, well, it seems easy, but it's not that easy. VNFs are not always playing nice. Everybody will agree with that. Virtualizing core functions into an infrastructure like OpenStack is, again, not that trivial. So those things are happening, and it takes a slow, painful time. And by the main reason is, by the time we finally get it right, the industry will have evolved and we have been completely obsoleted as a telco as well. So we need to move faster. Hence, we need a bigger boat. So the trick is pushing it forward even further. So if we make our network look like a big network policy, or pushing segment routing even further so that the network is really flattened as much as we can. So let's push it even more as we can, push SR to the host and VNS and all those things. So make a leapfrog approach to this. Then we can start leveraging mechanisms we're building with SR, which are SRTE, on-demand XF, or other technologies. In the end, we're pushing the limits so closer to the edge than we're really getting closer to the application. Our level is being able to offer a network service which is bound or is able to support the application. So, but why? Why do we want to make this statement? Is we want to make our network stateless. As much as we remove state from the underlying network and we push it to the edges, it removes a bunch of encapsulation, decapsulation, middle boxes, which we would like to remove, and in the end will probably be removed because virtualization technologies are evolving as well. We want to distribute function processing, virtualizing a physical box that does 100 gig of line rate throughput into a virtual function. If somebody's able to do it really easily without any problems, I would like him to talk to me, because that's not a trivial problem. And at the same time, we figure out that if we push it to the edges, doing smaller functions really close to the end user is really easier. Abstracting complexity is, for us, a service chain is not a service chain, it's a network policy. Services are part of our network traffic engineering mechanism, are part of what we will do with path computation, what we do with low latency links versus standard links. So a chain is not just one firewall connecting to another application, it's the end-to-end view. And that's what we call for us as a network policy. Being able to apply functions where they need to be, closer to the application and where it makes more sense. So for us, network policies are service functions, TE behaviors, and I put it as SRv6 end functions. I'm going to talk to it a bit later. So for us, a view of path awareness is, in a presentation I did on the P4 Summit, I talked to it about being able to do the network as an ASIC, so doing parsing at the edges as much as we can, doing classification. On that primitive, you apply network policies, which is anywhere in the network you can distribute the processing where it makes sense, and based on application requirements. So we don't expect, we need to have a better way of communicating the application needs so they can build those policies. For us, it becomes programming at all layers, programming the SID functions at the where the function should be, and or use SRT to be able to create that end-to-end network function, which is the network end-to-end policy. The demo we did was with SRv6, but could be done as well for SR and PLS. So one way to expect network behaviors is we don't necessarily need special functions to do something. So the example I'm using right now is one of the concepts we have with SRv6 and the SRH is we can encode a lot of functions into this. So we can say, for example, instead of having metadata to explain what a firewall is supposed to be, can you use a SID segment and say, here's a function, and the argument is the policy it should be using. So there's mechanism we can use to simplify a lot of messaging we send into the network. But the trick is always, well, it's cool, you can do a lot of those things, but how we can program those? So we implement SR on the host. SR on the host, you have a bit more flexibility on what you can do. So we have a lot of implementations right now. We've done SRH in Linux kernel, we've done SR and PLS and SRv6 in UPP. And for those who knew, we did the implementation of SRv6 in P4. So we can implement that in both ASIC and FPGAs, which really is interesting to us. But there's still need to do some work. So for example, it's cool, I have a data plane, it works with SR and PLS and SRv6. Well, OpenStack doesn't understand anything of this. He sees so that the construct to make it work in an orchestration platform is not the same. We also need end-to-end orchestration. So right now, everything we do in orchestration, like we are involved in ONAP as well, is based on other primitives than doing network policies based on SR. So we need to include that into our equation. So now we know how to program SR to the host. Now we know how to do to build a network policy inside the network, but what's missing? Well, we have challenges on the path awareness. Right now, one of the big focus we have is we're getting good at explaining a path to somebody. We can tell using PCE. The old time we use BGP, extended communities between providers, or BGP communities between providers who talk to each other. We can send an information to private to PVDs. The trouble is that's good. So we know how to tell somebody what to do. We have not really that much awareness of receiving the questions of somebody telling us what they need. And right now that becomes swivel chair emails or a big web portal with a bunch of templates telling us what should be done. So the question is, and the second part I'm talking about is there's actually work done in TIP, the Telecom Infra project, for those who are aware, where they were talking about how to exchange information between content providers and service providers. So instead of having to build a bunch of cache engines everywhere and oversubscribe the network, can we leverage some mechanisms? In that case, they use Alto as a mechanism to be able to exchange information. So what the provider needs, what the ISP is able to give, and based on that, you build a path that could be done. That was interesting work. But now, how can the app ask for a policy? And that's, I think, you can remove the sub-bullets of the first point, but right now what we need is a simpler way to express those network path requests. How can an application owner, or if you think about this, if we're pushing really closer to the application, how can an administrator or an application developer make a network request based on his application requirements so that he doesn't end up being needed to understand how MPLS VPN works or SRT works. And that the trouble is right now, so that we have a gap between what an application developer, pure application developer does versus what the network is able to give him. So there has been proposed ideas in that frame. For example, it was one about using kind of a DNS proxy, and I've put the reference to the paper there. But I think that for us as a challenge right now, if we want to move forward into our level, is we know how to program the network. We know where we're going with a single simplified data plane. The trick is we need to find ways to make it simpler for our external partners, external users, even customers, or our applications to ask the request to our network. Thank you. Any questions? Or was I here?
We have 10 minutes for questions, actually, so don't be shy.
Okay.
Hi, Brian Trammell.
Yes.
For these purposes, not the chair of Panrg. Can you go back Yeah, well, no, not that far. So the data plane is pretty clear, right? Like, so
Yeah.
this is all essentially done work. It's
Yes.
standardized to the point that you can buy boxes that do it.
Yes.
And the big question that I had, and sort of what, I was hoping you're going to come here and tell us how to do, was exactly sort of like the replacement for the control plane in SR routed networks and subnetworks, right? Like, so
Okay.
this is exactly what you're saying is what we need.
Well, the control plane has a lot of mechanisms.
Right.
So we can do it, implementing, to me.
Sorry, that's a terminology question, right? So sorry, but so when I say control plane, I mean something different. So I will use different words. A way to specify. So a way to act. So in the questions document for Panrg, we refer to this as how do you get the path properties down to the edge,
Yes.
right?
So giving path to the properties down to the edge for us, if SR, we're able to do SR data plane to the closest to the edge as we can.
Right.
Giving a path property there is quite easy. My challenge, we can do it different ways. We can do it with management plane, NetCom, gRPC signaling. We can do it with BGP. There's other ways. My trouble is, how can I know what the application wants or the customer wants to create that policy? Right now, we'll pre-assume, or there will be exchanges with emails, discussions about
Right, okay.
things, engineers in a room deciding on drawing on a board. Where I think we need to evolve is, how can that be? We're trying to automate everything. So
Right.
how can I automate the other way around? I can program a path if I have a unified data plane. But my trouble is I want the other way around. How can somebody talk to me in a way that is not Chinese? Sorry, there's Chinese people in there, but in the room, but it's not Chinese to everybody. So that's the trouble, because if you talk really going to application awareness, if you take network to network, that's a different approach.
Right.
If you think about application awareness, the app owner is really different.
Here, come on up. You know you want to.
Okay, so in the title you are talking about service aware.
Yeah. So
Seems to me what you are asking is how can I make the application network aware?
yes, in some ways, to me, to be service aware is I can be a service aware network policy, but then doesn't mean that my network policy is applied to the application what it needs. So I can build a bunch of services. Nobody wants them because I don't know what they want. So I want the other way around. So I need both ways. And right now it's one-way signaling. So there's a HuffNet meetings, papers, emails to decide I want this, and then okay, now we'll automate this to you.
Right. So
I'd
that
like to have the other way around.
Yeah, and so the big sort of science fiction vision that we have here is, okay, now all of this works, let's do an interdomain. And that won't, that doesn't scale within your organization. It certainly isn't going to scale
I make
outside
it
of it.
work in my domain as
Yeah.
me, and if I've done
Right.
it and I'm able to answer my customer's response, then I can talk to somebody else, my buddy on the other side,
Right.
and hey, now how can I exchange that information?
So you need
That's
a
your
faster swivel chair.
customer. Yes.
Okay.
Yeah. Well, you think about this.
Yeah.
The challenge in the end, at the beginning is not necessarily doing it's really able to go faster and agile and developing new services so that we don't end up still trying to fix something that by the time we fix it will be gone. And for us, the challenge is this.
Yeah. Cool. Thanks.
No more questions? Okay, thank you, Daniel. And the next presenter is Tom. Are you in the room? We have 13 minutes for the first presentation.
Sorry, I tested your joke for that. Okay. I just wanted to make sure that the thing would work.
All right, that's that. Okay, so apparently the joke's already started. My name is Tom Herbert, and I'm going to talk about firewall and service tickets. This was low. That better? So what we're trying to do here is this is a method for applications to signal the network. I think it kind of came up in the last presentation. And I think this has been a general idea that people wanted. And there's kind of a long list of laundry items. We want this to be extensible, expressible, have an application signal the types of service it wants, but also be able to do this such that if a service wants a specific, or an application wants a specific type of service, then it should be granted that service, and maybe somebody else shouldn't be able to kind of steal that service or use that same parameters. So this shows a long list of laundry items, efficient, dynamic. We would like to reduce the amount of DPI in the network in order to do stuff like this. And also not to enclose the internals of the network. So in some sense, these requests for service should be somewhat abstracted and work within a transport protocol. So today we know about diffserv. This is a wonderful mechanism, kind of limited in terms of how much information it can express, and also the controls. It's hard to control applications from just arbitrarily setting it. DPI has been used. That's been a little obsoleted because of TLS, so it's become harder and harder for networks to look inside the packet to figure out if it's cat video or not, and maybe what have you. Spud and Plus were some good efforts done previously. The idea was to do sort of signaling over UDP. So some of the ideas here are actually borrowed from those initiatives. There are a number of ad hoc mechanisms. One of the interesting ones was a proposal in TCP to add a TCP option to do some quality of service, and then applications could set this, and the network would somehow interpret TCP options. And there's a couple of other in-band signaling. The one that I have there is kind of a little more generic over use of extension headers like this one will also. So, but today I want to talk about tickets. And the idea of a ticket, it kind of is what it sounds like. When a packet wants to enter the network, they present a ticket. And the ticket gives you two things. It gives you admission to the network. So it says you're allowed to enter the network. And it gives you kind of the services that will be applied to the packet. So the idea is every packet gets a ticket. And when the packet enters a network, and I'll get to the meaning of entering a network in a minute. When it enters a network, the services are applied and the admissibility of the packet is checked. So when you have tickets, you need ticket agents. Ticket agents are going to be nodes in the network that provide tickets to the application. So basically the idea is the application sends a request to a ticket agent, and the request will be somewhat expressible. So it's kind of a one-time thing. So maybe a little more abstracted than just like bandwidth or priority. It may have other interesting characteristics. For instance, it may describe video characteristics in terms of frame per second or bit rate. So the ticket agent, once it gets this, then it can decide whether or not to issue a ticket. If it does, it gives that back to the application. And then the application arranges this ticket to be attached to its packets. So as I mentioned on ingress, networks interpret the tickets. So the tickets will be part of the packet. If it's valid, the packet is allowed to enter the network. If it's not valid, packet would be dropped, or there's some other alternatives. Tickets may be a little out of date, for instance, in which case we have some provisions for that. But once a ticket is accepted, then the ticket itself will indicate to the network the services that should be provided. And the network then can convert that into the network mechanisms to implement the services. For instance, it may go into network slices, could be encapsulated for segment routing as discussed previously, NFV, what have you. So one important aspect of round tickets is that they need to be round trip. So when the application sets the ticket in the forward path, so it's sending packets into the network, that's fairly simple. So the application just sets the ticket, it's sent into the network. However, in most applications, packets will come back for that particular flow. And the intent is that the application wants services in both directions. So the question is how to do that. And the answer is we will reflect the tickets at the peer and have them come back. So there's basically two variants of the same ticket. One is ticket sent in the forward direction, which means apply the services in this ticket to the local network. Packet leaves and it's reflected at the peer. And when the packet re-enters the network, say from the internet, that reflected ticket is then again applied into that local network, saying the services coming back down to the application. So tickets, like any other tickets, they need to be secure, so they're non-transferable. So if a network issues a ticket for a particular flow, for instance, that an application wants, only that flow should be able to use that ticket. So there will be some security and signing of tickets for individual flows, for instance. They have an expiration time. So I should mention that tickets are essentially stateless. So when the network is presented with a ticket, it validates the ticket kind of as a standalone thing. It does not necessarily create state a priori to process the tickets. And the other important aspect is the tickets are not interpretable by anyone outside the network. So one thing we can consider is that the tickets themselves may contain information that could be exploited. I mean, the very fact that we're saying this is video with certain rate, that in itself may be sensitive information. And the other reason why we don't want kind of tickets to be interpreted, there's no concept here of having global parameters for the network. So the local network may implement a service parameter that does not necessarily have to have global meaning, but could have meaning to itself. So no concept here of the global ticket system. So this is a picture of what the ticket flow might look like. So on the left, we have the host. First thing the host does, say it's creating a connection, request a ticket. And in that request, as I mentioned, it describes the types of services it wants. Ticket agent replies, and this is a ticket. It's kind of an opaque set of bits that the host will attach into packets. And I'll get to the mechanism for attaching it in a second. So the application then attaches the tickets to its packets for the flow. Each packet contains a ticket. Packets go into the network, and a maybe first hop router then interprets that ticket, reads a ticket, and then puts the packet into whatever network services are required. Then the packet traverses the provider's network, in this case leaves the internet. So once it leaves the internet, the ticket is still attached to the packet. It will actually flow through the internet, through the remote provider network to the remote peer. Now during that part of the path, the ticket is actually not interpreted. So it's just carried with the packet. At the peer host, the ticket is then reflected on packets being sent back. So if this is a request for video, then the actual video stream coming back will have the ticket attached, and that's probably where the parameters are most interesting. So again, the reflected ticket is not interesting to the local provider or the peer host, nor the internet. Once it comes into the local network through another device, that device will again interpret the reflected ticket and assign the service parameters within the local network again in the downstream path. Packet then goes to the host receives it. Host can also look at the reflected ticket to make sure that it actually is valid and one that it had sent in that packet. So that's kind of the complete life cycle of one packet. Here's kind of an example of what a video chat might look like. So the application, in this case a video application, may issue a fast ticket request. In this case, it's a video chat, 30 frames per second, with a minimal delay, 1080p, so maybe high quality interactive video. Fast decides whether or not it can service that, and will send back the ticket to the application. And then it kind of goes through the path that I described. So the application attaches the ticket, it goes through the network, the ticket is mapped into services, goes through the internet and reflected and what happened. You have a question?
Yeah, can I just ask a clarifying question on the previous slide? What happens if both providers have the same scheme? Can we?
So we'll get to that.
Okay,
That's
thanks.
a very good question. So actually, that's the next slide. So yes, tickets can be used bidirectionally. And in this sense, it can each use them, however, the uses are independent. So the ticket really applies to the network that they are issued in. So in this model, you can think of the network as kind of a dumbbell. So there's provider network, intranet, provider network. Tickets are applicable in the provider's networks. We're assuming that tickets are not of interest to the core network, that packets are mostly just forwarded. So in this case, each side can do the same thing. They would end up having 2 tickets per packet, One may be the local ticket, which would not be reflected. One would be the reflected ticket. And the way to tell this, so when a packet comes into the network, you do need to determine if the ticket is for you. Then it's a matter of looking at the addresses. If the destination address is local and it's a reflected ticket, that means that that's a ticket for the local network. Likewise, if the source address is local and the ticket is not reflected, that means you're in the source network of the packet that issued the ticket. So some specifics, so tickets, we plan to encode these in IPv6 destination options. Technically speaking, these kind of by definition should be hop-by-hop options, but I think the legacy of hop-by-hop options and kind of some of the requirements, there's a much greater likelihood there'll be drops and that might be unsolvable. And that's going to draw some controversy, I guess. Yes.
Aaron Falk. So what happens if the number of packets flowing in one direction is different from the number flowing in the other direction? What do you do with the excess tickets?
What do you mean? Each packet can have a ticket. So tickets are unidirectional.
The per flow ticket on every packet.
It's so is that true? It's a per flow ticket on every packet?
Yes, it can be per flow.
So suppose you've got 100 tickets going up, 100 packets per second going up, and 1,000 packets per second going down. How many tickets are on the downstream? What's the?
Each packet has at most 2 tickets associated with it. So
okay, and suppose there's 1,000 packets going up and 100 packets going down.
So, but yeah,
is it? Okay, okay. He's not saying that, so that's why I'm.
There's no state associated with the tickets. Tickets are per packet.
Great. You know what? I'll jump on you for the destination option thing at the end.
So, Fabian Schneider, NEC again. Why do you, what brought you to the insight that you only want one ticket in each direction? Why do you think it's not important to have the thing that you do to a packet that is ticketed in multiple domain networks?
You mean in the core?
Yeah.
I think that has a lot to do with, say, a mobile network. There's a lot of things the mobile network can do. So the edge does have a lot.
But I mean, your example is you want to provision QoS. If your QoS provisioning breaks down in the core of the network, you're back to zero, right?
So it is a little bit of a trade-off. We could do that. However, then we would need a more complex thing to identify the tickets. We thought of adding like an AS number.
Yeah. So are you aware of the service function chaining or the network service headers? I think they are called. I mean that goes in a similar direction. I know they are not kind of secure and all that, but it seems like I don't know. I mean.
Well, I mean it's the other part of that is, do you want to have a global system where say how do you implement a global priority? That's everybody's going to have a different concept of that, right? So we're trying to.
True. No, but
let's take the global priority question at the end.
Okay.
You have more slides.
Let me ask something different. So you might still want to have each network, have a ticket agent that assigns a ticket to its local processing, right?
Yes.
So, but you can't do it because you can only have one ticket per direction.
You get tickets from your local network.
Yeah. Okay.
If you wish to do something more elaborate, then you could do that. But then your application has to be contacting more than one ticket agent, right? It would have to contact other networks. So the other alternative here is if you want to schedule a whole path, then you can do that from the ticket itself.
Okay.
So you use segment routing, and you can route through the whole network. And so there are other options, right?
How large do you expect your tickets to be?
So that's an interesting question. I want them to be as small as possible. So the tickets.
You saw the unicorn at the front, right?
Yeah, I mean, okay, so we're already sticking 2 on each packet. So I mean,
tell you what, let me defer because I have some more information on that.
Okay.
Clarifying question on this slide?
No, yeah, same slide, yeah.
Okay.
Hi, my name is Uma, Huawei. Hi, Tom.
Hi, how you doing?
Yeah. So you said that it's a destination option or hop by hop option?
Destination.
Destination. So how intermediate node can verify that? It can?
I didn't understand.
Intermediate network node cannot verify destination option. Is it a rule like that, or it has to only hop by hop option, right?
The node that generates the ticket?
No.
No, the network which is verifying the ticket.
The network verifies, well, so I need to get into that. So there's a level of encryption here that has to happen because the ticket has to be verifiable.
Encryption
So it
is
has
one
to be
part, yeah.
signed with some addressing information also.
So encryption is one part, but putting in the destination option has a problem in the network node. It cannot see the destination option.
Because it can't process it by definition?
Yes.
That's an interesting story.
Okay.
So like I said, we
Second,
can make
that
it
was-
hop by hop options.
That was the
and
derail that I
illegal.
didn't want to start.
Hop by hop options are much more likely to be dropped
Yeah.
on the internet. So let's not get hung up.
So
on
that's
the
fine.
destination options.
No, my actual question is, why are you wasting extra space for this option? Why don't you put in your ILA? You have locator and identifier. Your identifier is your ticket.
Okay, that's an interesting point. I would say the number of bits we have available is fairly slim there, but yeah, if we could pull it in ILA, that would be great. Okay, so we'll encode ticket and hop by hop or destination options. I guess that's to be done now. They have a specific network encoding. They need some sort of encryption because they're likely, we want to avoid having them be exposed to the outside network. And they do need an expiration time. So again, they aren't stateful. So we're not looking at TCP flow state, for instance, to track tickets. So the option format, this is your typical option-like format. We foresee possibly that some could be modifiable, not modifiable. So that would have to be defined on a ticket basis. The only entities that could modify a ticket, obviously, are the local network that generated it. And there are, like I said, some tickets don't reflect it, some are not reflected. There's also an option to say you can't reflect it. And a ticket might look something like this. So there's an expiration time, verification data. So if we're doing HMAC, we would need some data there. And then the important part is what is the information that indicates the service. And this is where it becomes interesting because we obviously want to keep this as small as possible, but also fairly rich. So different ways you could do that. You could have TLVs if you wanted to, but that'd be kind of expensive. But we could also put this into some sort of index, into some number of common profiles. Could have a number of flags. The question of how big tickets are, I would hope that we can get these down to about 16 bytes, maybe less. That would kind of be my goals. So there is an obviously pretty rich control plane here. The applications speak to a ticket agent. This is most likely through some sort of library arranged by the OS. And the ticket requests at least contain the source and destination of the communication, possibly the ports. And then, as I said, it has some level of desired services. And this is expressed in some fairly rich format, REST, XML, what have you. Tickets reply should be pretty simple. It needs to be the expiration time so that the application knows when to stop using the ticket. And then the actual ticket itself. And that ticket itself, then the application takes and arranges to have attached inside the option. For TCP, that's actually a pretty simple thing. It's just a simple socket call saying, here's a destination option or hop by hop option. Please add this to all the packets. I should mention that the idea of tickets is once you use it, you can keep using it. There's no limitation on the number of times you can use a ticket, but it is limited by the expiration time. And also, when it's reflected, it has kind of that same properties. Whatever the last ticket is you receive from the flow, that's the ticket that can be reflected. So the peer doesn't need to track expiration times either. It just kind of opaquely reflects the ticket, and that's going to actually simplify the application on the peer. I'll get that in a minute. So here's kind of the components of this. So the application down at the bottom here, talks to the network, service mapper and firewall, and the ticket agent, and the local provider network, and then there's also another mapper and firewall at the top of the provider network. So implementation-wise, there is some work to be done. So the OS, we need to enable setting of tickets for applications. This is mostly done in sockets APIs, so it's not too much of an issue. There may be some priority or permissions things that we need to kind of allow. But we do need the library that allows applications to talk to the ticket manager. Applications themselves presumably would use this library, and the API would also allow it to be easy to attach the tickets. Server reflection, if we do that on TCP, it's actually pretty simple because we can do this completely within the stack. The peer application doesn't even have to know that it's reflecting tickets, so that's kind of nice. Connectionless protocols like quick servers would actually use the API to reflect tickets. Network support, so tickets can be standalone, the network processes. One thing that's probably pretty clear is if we're doing encryption, we can't decrypt on every ticket, so we could establish a cache. So the first time a ticket comes in, establish a cache entry, then subsequent uses of that ticket can easily be validated through the cache, so it should be more amenable to an MPU kind of implementation. And then the network and the firewall service mappers need to be modified. So one of the things that will probably come up very quickly, since we're using extension headers, and since we know those are unreliable on the internet, what does this mean for this proposal? So there are some different types of drops. We may see destination reachable on the forward path and we're getting replies, but the ticket's not being reflected. That may mean that reflection is not enabled. So that's half the path might be working. And we can actually kind of maybe create soft states, at least on the forward path. For the reverse path, you would create, maybe hopefully use that soft state if you get a symmetric path. If packets are dropped in both directions, that's a little less pleasant. Obviously, we can't have communication stop, so in this case, we need to back off from using extension headers. In that case, it's less likely we could use the tickets. Maybe we can, you'd have to back off to some sort of stateful mapping, kind of unpleasant. But the hope is that over time, the number of hosts or networks dropping extension headers goes down. Also, I think it's obvious that if your local network is supporting tickets, then presumably they're supporting extension headers. And at least your local network shouldn't be dropping them. And neither should be the peer. If the peer is actually doing reflection, hopefully that peer's network isn't dropping them either. So that's all I have. Looks like there's no questions. So. Oh, there is a question.
Hi, Alan Shalik. I had a question about, is there any way that you imagine either having the network attach something to say that actually I obeyed the ticket or followed the policy that the ticket implies, or conversely some way for the ticket agent to come back later and say, hey, by the way, there's been a change in the network. Actually, that ticket's no longer valid, to expire it early.
So that's an interesting idea. We haven't really specified a lot of the characteristics of tickets in terms of, does a ticket actually guarantee you something, or is it best effort? And I think that for the mechanism, what I think the implication there is it's probably true that you could do that. In that case, it makes the API to the application a little more interesting, possibly, because now you have to actually receive messages, asynchronous messages. I don't see any reason why you couldn't do that. Also brings up the question, how dynamic would this process be? If the network's constantly changing or the application is changing, do you want to be able to change tickets every 5 seconds? I mean, it's all possible. And obviously, the more interaction you have with the network, trying to fine tune this, the more control protocol and things like that. So there are going to be trade-offs.
I mean, you mentioned, for example, firewall is one of the things you might want to control with a ticket. And in that case, people might actually want to have some indication that it really had been done.
So what would the indication be from the firewall? So the ticket should establish your admission through the firewall, how would it change?
Well, for example, supposing you were requesting something from a site that you thought might be dodgy and sending you dangerous things back, and you wanted to make sure that a firewall actually checked it before it received your. I know it's a layer violation, right? But there could be cases where you actually are saying, I really want the network to perform this function because I'm relying on it.
Yeah, I think that would come out in the services in a sense, right? What the services could have a very broad meaning in this context.
Okay, yeah, Richard Young. And a very quick clarification question. So looking at your servers or router state, essentially, I guess that your index or profile index is only the services, not, for example, matching condition. I was imagining would be like a matching condition of the packet and the type of service. Basically means somehow for the server or for the router state, you don't keep track of matching conditions. So if you don't, what do you prevent from other people overheard about the ticket and reuse? Essentially, how to prevent, for example, binding between the packets and the ticket. Someone else overheard about the ticket and can also use it. But if you do a binding between the matching and the tickets and the services, then why do we even need the ticket? Just because the server now can already do classification, use open flows, and then why do we even have tickets then?
Well, because that would be stateful. So, for instance, if I wanted to attach a ticket to a particular four tuple because it's a particular connection,
right,
then the ticket itself could indicate the four tuple to match it against. So in some sense, the ticket becomes signed based on the four tuple. So the thing I'm trying to avoid here is to create a whole bunch of state in the network for every flow. And this is really one of the things we're trying to avoid. So in a stateful firewall, you have to track TCP, and that gets us down into a whole bunch of DPI issues. So one of the prospects of tickets is trying to avoid stateful tracking inside the network.
So basically,
now, that's different. We do some soft state tracking. That might make sense.
Sure. So basically, one way to understand is you are making the matching part of the ticket, and the central packet state to carry the matching, and the service qualities will be carried in the router. Is that really right? One way to understand it?
Well, think of it this way. So if we want to say this ticket's only valid for this four tuple,
sure,
then we just take a hash of that four tuple, and whenever the packet comes in, we hash over the addresses and ports. If it matches, then we know the ticket's valid after some sort of decryption. So again, all of that could be encoded fairly simple in a map or in a cache, so we don't have to go through the full check process each time.
Sure.
So just real quick, hold on, could you state your name again for the note taker?
Oh, Richard. Yeah.
Yeah. Thank you.
Rüdiger Volk, Deutsche Telekom. First, a note, I would not be optimistic about getting support for long header chains anyway, for any reason. Okay. Then I wonder, it looks to me, I'm an interdomain routing guy. Looks to me like you are essentially taking care of stuff that happens in the originator's domain. As you stated, when it crosses the domain boundary to the next provider up, kind of things are just passed transparently and cannot be interpreted. So kind of a clear statement of what kind of service can be controlled this way, I think would be in place. For going interdomain, have you really thought about that?
No, but
just one hint. You actually made a remark where you were saying, yes, the application would have to negotiate with the upstream providers. That's not realistic. If you actually think about it, you would have to come up with a proposal how the providers have their agents negotiate the tickets.
Right. So actually, that does bring up a good principle here. My preference is the only entity the application talks to is the local network. because in some sense, that's the only entity it trusts, and only because it has to trust. And what I really want is, I don't want any information about the path other than I know that that network is in the path. That's really the only thing the application should have to know. So the fact that this packet is traversing some other providers, from the application's point of view, since that's not local, that should not be relevant. So in that case, yes, you're correct. If there is to be more negotiation of this path, then that would have to be something that's initiated by the provider to the next network, to the next network. But I guess that makes the difference very noticeable. This is only because of the application talking to the network. Now, if this is the case that the provider is able to do that, then the ticket that's attached, maybe the ticket is known to outside providers, but the application doesn't know that. The application, all it sees is a ticket, just an opaque stream of bits, has no idea what that means to it. The network can actually assign more semantics to it if it wished. I think that's going to get into some complexities, but if you wanted to do this kind of inter-domain ticketing, then yeah, I don't want the application to have to negotiate with 5 domains just to get its packet sent. That would be kind of crazy.
Hi there, Daniel Kahn-Gilmore, ACLU. So I'm trying to understand the implications of this type of scheme in a scenario where the network may be adversarial to the user's interests. For example, the network provider may not want to deliver voice traffic to the user because they want to sell the user their voice traffic, which comes at a premium. So do you have any plans for how this scheme could be used in a way that doesn't?
Are you putting the net neutrality question?
I didn't say the word net neutrality. I'm asking about a situation where there's a network that might be adversarial to the user, and if there's a way that a user can protect themselves.
So I would view it this way. Like I said, see, the user in a sense has to trust the network. I mean, they're getting service from the network. That adversarial to the users, I'm not sure how much we can do. If the user says, I want service A, and the network doesn't provide it, then that's a problem. And this did come up as having lunch before. We do need a way to allow the application to verify the service they're actually getting. So you do need that feedback, and presumably you can't trust the network to say, oh yeah, you're getting that service. So the application would have to decide if it's getting the service it paid for in that sense. But I'm not sure what else you could do. So yes, this could be misused by a network that's adversarial to its users, no doubt. I'm not sure that's a good starting point for architecture. Does that make sense? Or?
I think I agree with you.
Okay.
I'm not sure that we come to the same conclusions about what to do about it, but I think I agree with you.
Frank Rogners. So 2 questions. First thing, can you envision a mode where you have a ticket per packet and the ticket is individual per packet?
What per packet?
An individual ticket per packet. So the individual ticket is individual and unique per packet, so that I can actually identify the packet in a unique way by the ticket.
So you want to attach an individual serial number to each ticket?
An individual serial number that is secure, because then you're kind of evolving along the path of what we're trying to solve with proof of transit.
So then
because this sounds a little bit like proof of transit on steroids.
You need to take an HMAC over part of the packet.
Correct.
Yeah.
And secure that. Yeah. What that would mean that you got to go and assign every single packet a ticket.
So there is one thing I didn't mention. It would be nice if the application didn't have to request every individual ticket. Say the application is creating thousands of flows or aggregating millions of flows. It could become kind of costly if every time you needed a new ticket, you had to
Correct.
ask the network agent. Also, the tickets may expire at a higher rate. So one of the things we are considering is there a way to allow the application the power to generate some number of tickets kind of autonomously? So these tickets would still have the same properties, and the network would know that the application generated these tickets. But the application within some small space could generate a block of tickets. And we see the same thing in ILA if you were at that conversation yesterday with hidden aggregation. So we want the network to have secure identifiers in some sense, but allow applications to actually create those on a small scale. So then instead of having to create each individual ticket and give it to the application, what if the network could just say, okay, you can print your own ticket booklet, you can print 1,000 tickets, and here's how to do it, and I will honor those 1,000 tickets. But beyond that, I can't do that. If somebody else tries to spoof you, I will detect that. That's what we would really want in that case. So per packet ticket could be done that way. But I don't think it's reasonable that you could request a ticket for every packet from a network agent. That would obviously kill the network.
So second question is, have you looked at other encapsulations other than V6 and using destination options? What about V4? What about MPLS? What about?
I think those could be kind of leveraged. Yeah.
Quick, you already answered this clarifying question. How big are these tickets?
So my goal is 16 bytes.
Okay. Because there's a lot of places you can stick 16 bytes. Anyway.
So I figure IPv6 address 16 bytes.
Yeah.
I don't know if you're familiar with the DLEQ work that was discussed at CFRG, discrete log quality work that's being used for privacy pass. Are you aware of this work?
No, I'm not.
So if you're thinking more about what types of ticket issuance you might be interested in, where a network provider wants to sort of bind itself to the mast and be a good citizen and prove that it's not doing certain kinds of things that users might not like, you might want to look into ticket issuance that's a blinded form of ticket issuance. So that the network, it limits what the network provider can do and provides the user with more autonomy. So if you're interested in looking at how to do more equitable ticket distribution, take a look at the DLEQ work that's coming out of CFRG right now.
I see. So you basically want the anonymous request to come in somehow. That's an interesting idea.
Yeah, Chris, but just commenting on DKG's comment, it's possible to verify these particular tickets in batches, so that maybe will help performance if you do want to go down that route. So if you are interested, we should talk more about that.
Yeah, and I'd like to cut the line after the last question, okay?
Okay. Hi, my name is Uma again. I like the idea of, application generating its own ticket space. It has to HMAC it, that's it. Your provider has the key, you just MAC it, and you don't have to talk to the agent to get the ticket, and you can do per packet.
Okay.
Thank you.
Thank you very much.
Tommy.
Hello, everyone. Hi, I'm Tommy Pauly from Apple, and I'm just giving a very quick pitch, just a 5-minute little pitch here for some work that's going on in TAPS, which is tomorrow morning. So I think this was actually talked a little bit about last time at Panrg discussing post-socket API stuff, but I want to present the work that we're currently doing for path awareness in API for transports. So here are just 3 thoughts that we're trying to incorporate into our API models as we're trying to look at how to give more path and transport flexibility. We want to make sure that APIs allow applications to expect multiple paths as the default. And so it's interesting to think about how APIs can be designed to not just think of a single connection as one set of IP addresses on one path. We're also trying to consider how applications and protocols can handle path changes gracefully. And what this means is that when we're dealing with multipath, things like MPTCP, things like Quick becoming more path aware, more mobile, is this done in a way that requires a lot of application interaction, or is it done in a way that can be done seamlessly, that can be done in a, without much interaction or disruption to the actual service itself? And another thing that's important to note is that we don't want our APIs to constrain future multipath or path-aware protocols. As we're developing new ideas here, how can we make sure that the APIs that we're designing don't end up limiting ourselves in some of the ways that sockets APIs have limited our ability to cleanly do multipath today. So these are questions that we're all trying to consider. If you have thoughts on these, please come tomorrow and try to incorporate them and give us feedback on the way we're going. So specifically, we actually have 3 new drafts in the TAPS working group. Please do read them. There's one top level one, which is a architecture draft talking about, what's our general approach? What are we trying to abstract away here to make it more flexible around paths, to make it more flexible around protocols? There's a document that covers the API, what we're describing as the abstract non-language specific API for how we can have applications interact with this model. And then we're also working on a implementation guide document that talks about how you actually translate these concepts and how do you get into the nitty-gritty of taking those concepts and putting them into the protocols, and specifically for path awareness, what does that translate to for MPTCP and others? A couple highlights I want to point to in the architecture and the API. We have the concept of path selection properties. So rather than allowing the app to be involved in every single path change, the application can specify the properties that it wants the system to take on its behalf around path selection. What paths are preferred, which ones are allowed, which ones are prohibited. We believe this is a pretty clean way to allow multipath. There's steps during connection establishment of candidate path gathering and racing. So we look at what are all the different protocols and paths and endpoints I can talk to, and let's actually try multiple of them. And this is how we're trying to get that flexibility during connection establishment. There's also the notion of reading and writing using messages rather than just having byte streams, even when you're going over protocols that may use a byte stream like TCP. Hopefully this can help the underlying levels schedule better if they have notions of which types of data have different levels of priority, different levels of urgency, dependence between each other, such that if we're using multiple paths, we can take advantage of them, of the paths well. And we also have the notion of path properties changing and allowing the application to some degree be able to react to path changes. So anyway, the next steps, we're going to be talking about this all tomorrow at TAPS. If you're interested in this type of work, how APIs can allow our protocols and our devices to become more path aware, please join us. If there are concepts that you think do need to be exposed to promote path awareness, please come and let us know. And also, if there are concepts that we're adding into these that maybe are harmful to path awareness, that are actually constraining future use cases, also please let us know those. We want to make sure we have a good future-proof design here. And that's it.
Thomas Eckert. So which of these drafts would be the best to read in terms of summarizing the experience you've gained from revisiting what ICE has already done?
Yes. Right. Colin's in the room. You want to step up here? Colin. Yes. So, right, we are working on incorporating that. We have some of the text there. I think that would mainly be in the architecture and API documents. The architecture is a fairly brief introduction to it, and then the API is trying to describe how you interact with that. But Colin, please take the mic.
Hi, Colin Perkins, co-author of some of these drafts. Yeah, the architecture and the interface talk about this a little bit. The implementation draft has a much longer discussion, although that needs to be revised and brought up to date still.
Yes.
These all have 0.0 in the name.
Right. These are all 0.0. They've been written very freshly, and that's especially one of the areas that we believe needs to be fleshed out. So I'd say take a look at what we have so far.
I mean, the idea is certainly to incorporate the ICE algorithms and happy eyeballs work into this. Yeah.
Aaron Falk. So I think it's worth pointing out that this work is compatible with the socket intents work that was discussed earlier today.
Yes, that's correct.
Spencer? Thank you very much.
All right, thank you.
So I'm Spencer Dawkins. I'm the outgoing transport area director. I don't step down until next March, but I just like saying it. Next slide, please. So I'm here talking about roads not taken. From the first Panrg meeting we had at IETF 99, Oliver did a great presentation on our experiences. It's called a decade of path awareness. We learned two things from that presentation. We have a lot of experience with path awareness over the last decade, and we have very little experience with getting path awareness deployed. So what we decided in the room there was two things. Again, first, this stuff is mostly research, so proposing research group done. And the second is we need to write down what we've learned, and Spencer finally started doing that. Am I going that way? Yes. Yep. Cool. So this was submitted yesterday morning. It's only a start. The thing I want to call attention to on this slide is that this is providing the rules of engagement. We don't need to describe every idea, but we need to learn every lesson. Please contribute subsections from your own experience, and please send GitHub pull requests to do that. URL is there. The requested format for contributions is in section 3 of the draft. Please send comments about stuff that you see in the draft, revisions of the draft to the mailing list. I described my own learning experience, triggers to transport or TrigTran, just to get things started. There is no shame in describing your own learning experience. And I want to be real clear about that. This stuff was research, even if we were trying to engineer it. Other way, yeah. Yep. Oh, sorry.
There we go.
Cool. So what my contribution looked like, which is section 4.2 of this draft, is a short description of 2002 era TCP timer behavior problems, a lot of which had to do with TCPs that would back off for a long time, exponential back off. So if your link has been down for a while, you've backed off for a while, even if your link comes back up. Provide a short description of what was tried to improve things, which was basically saying, oh, can we get hints from the first hop device that saw a link go active, basically. Providing my summary of the lessons learned as far as I was concerned. First, to give you an example of what I'm thinking about here, is that you can't add complexity if you don't take complexity away. We had problems with basically saying that if you were worried about congestion, for instance, that in congestion you can lose triggers. You can lose the signal that you're hoping to find out about to speed up and slow down. It turns out that that's really awkward, so it turns out that the TCPs leave all the mechanisms in there that they would use to recover if they didn't get a trigger, which they don't get today anyway. So basically all we could do is add complexity. We couldn't take complexity away. A related part of that was that come on, this is 2002, right? Everything was unauthenticated. I'm not sure we had deprecated plain text passwords yet. So basically saying, I'm making something up a little bit here. There was a previous thing called L2 triggers, and if I'm remembering correctly, and some of you all may know better because I wasn't involved with it, that was more of a I want to be passing triggers up and down the network path because things go up and down in the network too. And basically, we said, this stuff is all unauthenticated. The best we can do is trust the next hop device. And even that, we said, well, fine. The transport community was a lot more happy to get triggers to slow down rather than to speed up. Third thing was, if you need support in the network, operators will want to bill for that. And what we were providing was not a big enough benefit to where they could sell this as a service distinct from other things that they were selling. The way this falls into the draft is that this got stuck in as section 4.2. In section 2, which is a summary section, I tried to do a less detailed version of these lessons. My suggestion to people who have experience that I haven't captured, which is basically all the experience we have except for triggers for transport, my suggestion is to look through the section 2, and if you learned things that aren't there, please consider contributing a section describing your own learning experience. Based on the conversations that we had at Oliver's presentation at IETF 99, I stuck a thing in there for IntServe. I stuck a thing in there for Shim6. It is becoming increasingly obvious that I wish I had started writing the section on Quick Start 2 years ago, because the other reason I said I'm a transport area director is that I think Miri and I would appreciate an awful lot if people were capturing this stuff, because a lot of it tends to end up coming back into the transport area, and we end up learning the same lessons over and over again. So the transport area directors, am I speaking for you correctly, Miria? You would agree with that? This is going to help us? Yeah, she's nodding. She's nodding. Good. It's Monday. It's Tuesday afternoon. So I'll stop there. And
so
yes.
Actually, Torlis, before you have a question, I'd like to see a show of hands. Who here, primarily layer 3 or layer 4, but anything else is fine. Who here has learned lessons about things not to do ever? Keeping in mind, if your hand doesn't go up, you never get to comment at the mic again.
Brian, if you could do that for the remote participants, they would enjoy this moment as much as we did.
Who has a lesson that they would like to write down and help Spencer fill this document out? Gory, Torlis, 2. Okay, the rest of you may be able to speak at other mics, but not this mic. 3 back. Okay, so a few. So get in touch with Spencer, please, and we'll try and get this. Try and move this forward for a 0-1 for Montreal.
So like I said, if you are a person who can contribute text on Shim6, on IntServe, or on Quick Start, that would be fabulous. 2 of those sections are already in there in blank, and it says your name goes here, provide text. But that's only a beginning. Honestly, I'm kind of considering that this is going to continue. This is going to be a living document for a while. Because we continue to learn, as well as continue to document the things that we've learned several times. And I forgot to raise my hand when Brian asked for a show of hands, because I was laughing so hard I didn't remember to do that. So my hand went up too. So that's, like I said, that's why I'm section 4.2. Questions?
Yeah, so I mean, this looks as if life is easy. I mean, I would revert the whole thing in terms of saying we can make pigs fly. We actually have a pretty good track record of doing that, as long as basically some people thought that there was business behind it, right? And sometimes there actually was, and we have flying pigs in network. So simplicity and sane architecture aren't really the best or necessary requirements to sell things in the IETF. The support in the network, operators want to build for that. Yes, that is true, but you should really replace it with service providers. I think that's what you're talking about. I would make the argument that there is a lot more money to be made in networking if you eliminate service providers and look at people running their own networks, right? There are so many of these markets, and starting with your home network, starting with a lot of the enterprises where the margins of acceptance are completely different. And even when you look at service providers, and I've got my experience with IP multicast, where we still haven't gotten what we wanted to do in 89, which was get multicast to home users, because yes, the business people didn't figure out how to monetize it, whereas it's being used everywhere for IPTV for their internal use.
Section 4.5.
just saying, right?
I see it coming.
I think I see a lot of. I was just pointing up on that because I see a lot of people in the IETF very narrowly looking at services providers can sell, which is a nice, interesting segment of the market, but it's not the market.
I agree with what you're saying, and the thing I would say also is that what you're describing, if it got deployed, it worked. Those are not the people that frighten us. It's the ones that we spent a lot of time doing something. We spent years on Chimp 6, and it wasn't deployed. What can we learn from that? That's section 4.3. If someone would like to take a swing at that, this is there may be a excellent companion draft. It's that basically says if you know everything that's in the other draft, here are the things that are going to work for you. That's a really reasonable suggestion.
Hi, Spencer, it's Gori. Yes, I think this document would be really useful for me to show people when they come up with new proposals, because a lot of people spend a lot of time wasted here by going through things we've already done and not understanding that they have to talk about those first to kind of clear the ground. So this is really good. It might be difficult to remember the things that completely went wrong, but we should encourage people to think about those as well, because a lot of buffs around this.
So, I think it is fair to say that one of the things I'm expecting to do as editor on this draft is some structural maintenance kind of things, saying, was this rejected by service providers, rejected by operators? Was this trying to violate the fundamental laws of physics? There's different categories of things that we've learned. I think, like I said, I think all three of these learnings from TrigTran might go in 3 different sections.
So Aaron Falk again. So I just want to point out the IETF doesn't have a monopoly on bad ideas here. And in fact, 20 years ago, the TCP over Satellite Working Group was created largely to inform the satellite industry of what not to do to try to solve their problems. And RFC 3819 is a really good summary of that. And I think that, that's such a small number compared to the current RFC state that I wouldn't be surprised if a lot of people haven't looked at the TCP SAT RFCs. But that's there's a lot of mechanisms that I think are floating around in the Panrg space that are tied to that. And one of the big insights that came out of that, and that I think are reflected in the things that you're trying to capture in this document, are to avoid assuming that the internet looks like the piece that you're familiar with. And that's a frequent fallacy. People come in, they try to solve a local problem using IETF protocols, and they forget that the internet's actually really different in lots of different places.
Cool. And thank you for the observation about TCP SAT, Aaron. And if that sounded at all intriguing, watch for the announcement of a mailing list within the next week on something kind of interesting. Any other comments?
Thank you very much, Spencer. All right, I'm going to set myself up.
It is always a pleasure.
Full screen. Hi. Oh, this is an edible mic. Okay. Check. Hi, I'm Brian Trammell. I'm speaking now as an individual. These are just sort of some of my thoughts on ways forward. So, I mean, we've had a bunch of presentations where we were talking about path awareness. I wanted to put my definition of this up here. That's sort of the science fiction, far future IRTF sort of way of looking at this. And I would say that an internet working architecture, a way of building together networks with a stack of protocols, is path aware if the network explicitly exposes information about the paths to the endpoints and allows endpoints to have control over the paths over which their traffic will be sent. This is the best definition I could come up with. There are many other definitions, all of which I think capture some part of this, where we're talking about getting information out of the network so that you can do things, so that you can schedule which packets are going to get sent where. That's why this research group has a large overlap in the transport area. and information about sort of like path control, which is why we're hearing about segment routing, so on and so forth. The current internet architecture, if such a thing exists, is not path aware, but there are a lot of IETF technologies that we could use to build one. So this is one of the reasons that we propose this as a proposed working group, is to have a place to sort of work this out. Why do we want to do this? A big sort of driver for transport people is, hey, we're doing a lot of work on multipath transport protocols. These only work in situations where you're multiply connected, where you have a different or even wildly different characteristics on your access interfaces. It would be neat if we could generalize this beyond just these cases. It would be great if singly connected multi-home devices could maybe get some of the control that you get and some of the benefits that you get out of these multipath transport protocols. We'd like to look at alternate architectures for routing and the trustworthiness of routing information. We'd like to look at ways that the endpoints can cooperate with these things. And we'd like to experiment with cooperative signaling for path properties and path selection. What have we done so far? We've had 3 meetings. We have this vision of endpoint participation in network paths. We have a set of open research questions, which I brought into the Singapore meeting. We had some good discussion on those, and there's a new version of these we'll go over in a second. We have a venue for discussion of topics related to endpoint control of path selection. That's what most of today was about. We had many interesting proposed talks to come in and say, okay, well, these things are all kind of related. Let's get together in a room and talk about them. And we have some interest in questions and discussions, but if you look at sort of the, if you can call the output of a research group or the traffic on the mailing list, not a lot of energy in terms of answering them so far. And I'd like to kind of ask questions about, how can we do better? So these are the open research questions. This was what we started with before Singapore. We refined it in Singapore. How do we define and represent the properties of paths? One of the things that's happened in the meantime is some of this work is possibly going into the TAPS working group in the IETF. How do we get access to trustworthy information about path properties? Right now, the endpoints measure it themselves. I mean, so basically everything in the socket intents work is based on getting data that the kernel's already measuring. Can we do better than that? How do we give endpoints control over paths selected for given traffic in a way the network can trust? Well, you can do it with segment routing if you magically fix the interdomain problem. That would be, I'm missing a unicorn up here in the top left. Maybe Tom can help me out. And then what do the interfaces for this stuff look like? And it looks like TAPS might be taking this on as well, because the protocol stack selection and path selection problems are sort of pulled into this emerging TAPS architecture. Looking down the path of the science fiction road, once you have ubiquitous path awareness, you don't necessarily want the applications to do all the heavy lifting of figuring out what goes on which path. You'd like to design transport protocols that can do this. We had a talk about this in Singapore. This one actually came from Singapore. When we talk about, or when I talk about path awareness coming from sort of like my research background, I think very much of endpoint, network, endpoint, and it's the endpoints, and the endpoints are running the applications. But it turns out that actually a lot of these topics come up in managing networks that you're building out of tunnels and overlays, and there's an opportunity, I think, for interchange. How does this vocabulary, how do these interfaces change when you're implementing this from gateway to gateway as opposed to endpoint to endpoint? And then there are sort of the big like layer 8, layer 9 questions. If you start giving the endpoints control over where their traffic goes, now you have a control loop at the ends and a control loop in the middle. You don't necessarily want to sort of cross-drive what the endpoints are saying and what BGP is telling the network where the traffic should go. So that's open and researchy. And then there's the architectural question of that I think is going to show up again and again and again in I thought it was going to be called Draft Dawkins Panrg Don't Do This, but what not to do is also good. Is that, okay, well, we built a thing and there were no incentives for anybody to deploy it, so nothing happened. I think there's a continuum here, and when we started this research group, we thought we were talking, or I thought we were talking about this: full network support for path properties, endpoint determined interdomain routing, blue skies and unicorns for all. Where we started is here. What's a path, right? And one of the the interesting things about like looking at the presentations we've had over the past 3 meetings is there's a continuum here, and there's actually a lot of stuff, a lot of which is already there, right? Like so, any transport protocol or transport overlay that's doing in-transport measurement of what's going on a single path and might remember it is inherently path aware. So socket intents is a little farther down that path. But most sort of working TCP implementations now will tend to remember what works, what doesn't, what the RTT was. Can it, should it do something with initial window one, and so on and so forth. There's the PBD work, which gives you local link path properties explicitly. That also exists. And that's also a little bit farther along this continuum. Multi-path transport protocols exist. Application access to path properties, we're not quite there yet. But well, application access to path properties, that's how socket intents works, right? I mean, it actually goes in and it asks the kernel, and the kernel gives it information about what's going on, and then yeah, exactly, right. It's a little hand-wavy. And then local network path control. Well, you can do that with segment routing in a situation where you already have information about what each segment means. But I mean, like all of these things are sort of there, and they're all sort of along this continuum. And I think that we could have a very productive research group if we focus on sort of over here and moving up here. I don't think we need to really go all the way down into the bright, shiny unicorn science fiction future. But we should keep it in mind. So that's just my sort of thought. So from that, what next? Everybody who raised their hands because they want to keep speaking at the mic should talk to Spencer. Please contribute to draft documents, Panrg, what not to do. When we're looking at the space of technologies and questions to tackle, I think another session or two like this, which is really just sort of solicited talks. Hey, come and if you have something that looks like it fits in this space, hey, let's all talk about it together and discuss. I think that could be useful. With respect to moving forward as a research group, if what we're going to do is write documents, maybe we can do that. We also don't have to. How should we increase energy in the research group? Should we focus on a few questions? Should we look at one end of this continuum? Are there other questions to consider? And what I would say, again, as individual is, if people have found the questions doc useful, is that something that we should adopt and publish as the research group? So with that, I'm going to sit down as an individual and open the line to comments and discussion. So this is really about, and then at some point, Allison will jump up and do the IETF chair thing, I presume. Oh, do you want to do that first? Come on up.
That's okay. So I'm Allison Mankin. I'm the IETF chair. We chartered this as a proposed research group, and it's having its 3rd meeting. So it's now time to decide, shall we make it a full work research group? And I would like to get the sense of the room that there's commitment and interest to keep working along the lines that are here. And then, then I think you can devise what the plan is. But, a reminder to everybody that I want to make sure that these are good uses of people's time and that we get good results out of these research groups that can lend themselves towards, more enlightenment or, potentially IETF engineering protocols as well. So, can we? I think we'll just do a hum. Could you hum now if you believe that this research group should transition from proposed to full status? Okay, now let's have a hum of those who believe that it, and if you're at the mic, yes, you probably should cover like you did. Thank you, Charles. And now another hum. This is for those who think that it should not transition, and that basically means it really doesn't get to keep meeting formally anymore.
The air conditioner doesn't.
I don't hear any other humming though. You want to comment, Spencer?
Spencer Dawkins speaking as transport area director, one of the two transport area directors, just the outgoing one. My take from my place is that this work will happen, and the only question is whether it happens in the IETF where it belongs, or if it continues to happen for another 20 years in the Internet Engineering Task Force, where Allison was the sponsoring AD for TrigTran. This is why she liked that answer.
I get to sponsor it again.
Okay,
so we'll go. What?
So you have an answer.
Oh, I haven't answered yet. I can leave the stage now.
Or you can stay up here.
No, I'm done. It's okay.
Thomas Eckert. Yeah, so two points. Is just one about, what is the scope of the research, right? I think everybody loves to be a technologist and just, do research on these wonderful technology aspects in here, but quite frankly, and I think Spencer's draft is alluding a little bit to it. I think there are two other really important things to understand. One is business and the other is politics. And, if I look at the history of what we've tried to achieve here, and let's say, for example, privacy as one of the important, policies, I think it would be good if people would be willing to stand up and actually summarize also, business aspects and policy aspects in a way that we know what's either feasible in the IETF or what we need to make become feasible in the IETF in that respect.
So I'm standing up here as author of the questions draft. This is kind of what I was trying to capture with these last two questions here. If there are other aspects of those questions that we should address, please send a line to the list or a PR on the draft.
And the other part with respect to your last slide, so I'm not that much motivated to constrain the work only to, let's say, data model one sucking path or 5 sucking path, but really something to do to get better path.
Yeah.
I do applaud all the people who do, and I'm, to the extent that I can contribute, help with that, but it's kind of just a boring place to stop, right?
Yep, understood. Well, so that's where I hope the science fiction comes in, and I hope it's not as science fiction-y as I'm afraid it is.
Lee Howard. So the questions draft, I think, is important and will help drive the ultimate charter and the kind of work that we're specifically looking for. I may want to I may need to suggest some rephrasings for some of them. For example, we might want an explicit reference to the protocol transitions RFC. And I think that's...
There's not one in there already? I basically cite, the first
no,
thing I do when I write an ID now
I
is
might need to
cite
make
it,
some
and
changes
then
because I haven't actually read it.
Good.
Yeah.
Yep. No, I'm just surprised. It's a draft I wrote. It should cite it because I love that draft.
Rüdiger Volk, Deutsche Telekom. Once in a while, I go as an observer to research groups. And I'm going to drop out and I'm not going to do research. When I'm looking at what you were talking about, I suspect that the term path aware actually is misleading.
Okay.
And well, okay, once in a while, using misleading terminology actually misleads yourself. Your slide was saying, yes, the question that you were asking was, well, okay, what is a path? And I would question whether applications actually really want to know every detail of paths. I, as a layer 3 guy, don't really worry about what lambdas are used in my transport network. Right. So what I suspect actually is the crucial question is how to communicate about available and actually used services.
Mm-hmm.
And I think in some of the presentations, essentially the question, well, okay, how do we express that? I think came up as crucial questions. Yes, if you invent a rich repertoire of describing services that may even include the lambdas used in the transport, probably very irrelevant to most of the applications. But kind of starting with that kind of question and terminology, I think the chances of getting results that actually can turn over into something that is useful in business and in engineering, I think would get better.
Okay.
People who are told, well, okay, we are looking into the paths and make the applications network aware, that's not really what the world is asking for. In certain cases, maybe someone is interested whether a packet goes down south over the border from Canada and back.
Yeah.
And those are relevant concerns, but that's not really the crucial set of problems.
Thanks. Spencer Dawkins, this week or today is a IRSG member. So you're kind of like, what are the next steps? And I'm thinking next steps kinds of things might be to encourage people to, especially people from the IETF, to take a look at, I guess it's RFC 7418, which is basically, here's, if you're an IETF person, here's what's different in the IRTF, and here are the advantages of being in the IRTF. Here are the tools that you have in the IRTF that you don't have in the IETF, because the ISG is supposed to keep you from using them. I can say that. I wrote that document. But so for example, building community, increasing the connection with this community with people outside the current research group is, that's a thing. So I don't know if there is a right place for this research group to meet that's not co-located with an IETF, but you can do that if there is. So like I said, I'd like you to encourage people to kind of think big about that. If you and Allison and Jen decided that this was to this point, suggesting that the IEB sponsor a workshop to also bring in other people that might not be at a research conference. That's also a tool that you've got. So I would encourage people in here to think big and not think about how to do trig-tran, but this time we're going to get it right.
So yeah, I mean, from what Rüdiger said, I think it would be good to have, for all the drafts, some kind of self-classification where they think they fit into the spectrum, right? In terms of, this is a cool idea, which we haven't even figured out, really kind of, base research type of thing in one of the other aspects. And maybe on the other side of the spectrum where, a lot of us coming from development side and being frustrated with, okay, we think this is a cool technology that will work. It should be in the IETF, but yep, business or politics don't work out yet. So how far can we still drive it? Can we, have, the research aspects of what's on the business side, what's on the politics side in the research group help us to drive it over to the IETF? And that's just, two ends of the spectrum I can imagine. But the clearer we, try to self-classify the work we're doing here, I think the easier it is for people looking at all the work to figure out where they fit.
Matt Mathis. There's a lot of really cool ideas in this space. There are a lot of really simple, straightforward, valuable ideas that have never been deployed for a bunch of reasons. I'll cite as a simple example is we don't really have a scavenger service. This is a 1-bit service on top of other services. I can't say this application is running in the background. You can finish whatever. What strikes me is the most valuable thing for this community to do is to actually be a bridge between people who have good ideas and figuring out why similar ideas in the past haven't been deployed. That information sharing is something that's actually valuable. That's not the same as actually doing the research. So that means people presenting the research, talking about it, exploring ideas, and then saying, okay, what's the barrier that this idea is likely to hit? And helping people try to overcome those barriers. I'm very skeptical of big changes because of the scale of the internet, not because of the ossification of the internet. Oh, that may be an issue, but just the sheer scale.
At some point, one is the other.
Right. And the other thing that has a new perspective, I've been here for almost 30 years at the IETF. Actually, it is 30 years this year. Geez. The last 6 of which have been at Google. And one of the things that you realize at Google is the internet is the proverbial elephant in a room full of blind men. And it's different everywhere. And no matter how well you think you know you're part of the internet, somebody else's internet is entirely different than yours.
Yeah. So the last comment, and we're cutting the line because we're
Sorry.
out of time.
Yeah, Jake Holland. I would like to add that if we could add to the don't do this, maybe what to do, lessons learned that were successful, if we can think of any.
Yeah, it's the other draft. Yeah.
Oh, great.
Right.
Well, but
Whatever. What
cases like ECN, right, which are almost, Yes. Yes, but in the context of this research group, understanding the questions that did work out well is what I'm trying to say. Thank you.
So I assume we should ask the group if you like to adopt this question document. Yeah, so please hum if you think the document should be adopted. Okay. Please hum if you do not think it should be adopted. Okay, air conditioner still does not like you, Brian, but I still listen clear. Okay, thank you. And wait, before you leave, please raise your hand and freeze if you have not signed the blue sheet. Okay, cool. I'll come to you in a second because I do not want people sitting on the floor next time. I want to have a bigger room for this. Thank you very much and see you in Montreal.
This is yours, right? Yes.